All right, today, the 18th of November. My birthday is this Sunday, for those of you that are keeping track. Well, thank you. So you can bring your gifts in Friday. Friday will be fine for my birthday gifts, because I won't be here Monday or Tuesday of next week. Okay, so tomorrow's okay. Friday would be fine. Gift cards from Publix, one of my favorite places to shop. Peanut M&Ms are always good. Mountain Dew. Someone brought me some Mountain Dew. This one person brought me Mountain Dew and peanut butter M&Ms, peanut M&Ms one year. That was very kind. So just, mark your calendars. I can't give you extra credit, but I will be very thankful. Will I be what? Are they going to be in the wrapper? You might as well just buy me a whole bag. Well, if you're going to do that, you might as well just give me peanut M&Ms, because that's what I like. You know what I'm saying? Well, I mean, peanut M&Ms is fine, or a gift card to Publix. For my birthday present? Yes. From you just being here? Yeah. That's not enough. That's not enough. We need to go the extra. All right, overachieve. $100 gift card. That would be incredible. So just something to put on your calendars. Didn't want you to forget about me. All right, today we are moving into zero and negative exponents. So zero and negative exponents. And let's say this, number one, important, when simplifying exponents, there can be no negative exponents in your answer. All right, if you're asked to simplify an exponent, well, if there's a negative exponent, you haven't simplified it yet. Okay? No negative exponents in your answer. And then we're going to say this, that anything raised to the zero power equals 1. The number 1. All right, so a couple examples of the zero power. All right, 4 to the zero power. Well, that's equal to 1. Okay. -3 in the parentheses to the 0 power. Well, that's equal to 1. (5.14) raised to the 0 power, and that's equal to 1 as well. A variable, x, raised to the 0 power, it equals 1. Anything to the 0 power is equal to 1. Come on in. And here, this is real important. For every non-zero number, for every non-zero number A, meaning holds the position of A, and integer n, A to the negative n is equal to 1 over A to the nth power. That's how you simplify a negative exponent. Let me show you some examples of that. If I can get my screen to move. And here, put an and right here, and 1 over A to the negative n, well, that's equal to A to the positive n. All right, so here's an example. If you've got, let's say you got 7 raised to the negative 3rd power. All right, right here. Your A is 7. Your n is this 3. All right, so if you use this model, or if you use this rule, 7 to the negative 3rd is equal to 1 over 7 to the 3rd. And now, there's a button on your calculator that is right above the division button. The button looks like this. It's y raised to the x power, calculator button. Wherever that button is on your calculator, all right? That's what you use for raising a number to a power other than 2, all right? Because when you simplify 1 over 7 to the 3rd, you don't want to type 7 times 7 times 7. You don't want to do that, all right? In your calculator, you want to push 7, that y raised to the x button, and 3, and hit equals. And you should get 343. Because that's what 7 to the 3rd power is equal to. All right? So it's to do 7 to the 3rd, you push 7, you push this button, you push 3, and you push equals. Okay? It's the number. This means raised to this power equals, the calculator will do the work for you. All right, if you want to try it again, you can do 2 raised to the 3rd power equals, your calculator should say 8. All right, 2 raised to the 3rd is 8. If you got a to the negative second power, all right, if you're asked to simplify that, that's equal to 1 over a squared. All right, so here we go. We're going to do a few more examples here. We're going to simplify some powers. As soon as my screen moves. Come on, screen. There you go. What is the simplified form of each expression? All right out the gate, we got 9 raised to the negative 2 power. That's an expression. We're going to simplify it. 9 raised to the negative 2 power is equal to 1 over 9 to the positive 2 power. And then we're going to square that 9, so that's 1 over 81. This is a tough one. Negative 3.2 raised to the 0 power. What's that equal to? That's equal to 1. Good. You guys are alive. All right. Oh. How about this one? How about 4 raised to the negative 3 power? All right. We make that 1 over 4 to the 3 power, don't we? And then we go ahead and finish it up. So that's 1 over, that's 4y to the x3. And equals, anybody do it? Good, 64. You get any idea? 3 raised to the negative 3rd power. All right, that's 1 over 3 to the 3rd. That's equal to 1 over, what's 3 to the 3rd? Anybody know? Good, 27. How about 6 to the negative 1? That's 1 over 6 to the 1st. 6 to the 1st is just 6, so we can just say 1 over 6. All right, now one more here. We got negative 4 in parentheses, so it's the whole quantity raised to the negative 2nd power. So that becomes 1 over negative 4 to the positive 2 power. And that negative 4 that's in the parentheses means negative 4 times negative 4. Okay? Negative 4 times negative 4. You can do it in your calculator if you want to. I think you can do 4 negative and hit the x squared button, and you get 16. So this is 1 over 16. All right, so there's your simplified form of each of those expressions, and they're all dealing with negative exponents or 0 exponents. You guys all right with that? All right. Now we're going to continue with those same directions. We're simplifying. What is the simplified form of each expression? Now we got this. We got 5. A to the 3rd, b to the negative 2 power. Now, when you're simplifying these expressions, again, in simplest form, you got no negative exponents. Can't have any negative exponents anywhere. No zero or negative exponents. So watch what happens here. The 5. The 5 is raised to the first power. Agreed? It's implied. It's not written. So the 5 stays in the numerator. The a that's to a positive power, the a to the third, it's got a positive power, so it stays where it is, meaning in the numerator. And now what we do to get this b to the -2, that's not in simplest form because we need this power to be positive. It moves to the denominator and the power becomes positive. Just like the first 6 examples we did. All right. When you've got a number in the numerator raised to a negative power, moving it to the denominator to the same power removes the negative sign. Okay? Now, just like moving it from the numerator to the denominator removes the negative sign, so does the opposite. If you've got 1 and it's over x to the -5th, that's not in simplest form because you've got a negative power. So if moving it from the numerator to the denominator changed the sign of the power, moving it from the denominator to the numerator does the same thing. So 1 over x to the -5th in simplest form is equal to x to the 5th. X to the -9th, y to the -3rd. Simplified. Both the powers are negative, so both of those have to move. When I say move, I mean they got to move from the numerator to the denominator. So this becomes 1 over x to the 9th, y to the 3rd. If we got 3b to the 4th over n to the -2, again, the 3 is to the first power, but it's implied. So it stays in the numerator. The b is to a positive power, so it stays in the numerator. The n is to the -2 power, so it has to move. It's got to move to the numerator. And when you do that, the power becomes positive. So there's your simplified form. If you had a to the -4th over b to the -5th, what would happen here? How do we get those exponents positive? Say that a little louder. You flip them. Exactly. You flip them. You put the a in the denominator and you make it to the 4th power. And the b goes to the numerator to the positive 5th power. Very good. Any questions on the negative exponents? All right, so the last thing you're going to do today is going to be called evaluating an exponent expression. All right, so we're going to evaluate in an exponent expression, and we're going to say for this one, when s equals 2 and t equals -3. The expression is 3 s to the third t to the -2. So the first thing you want to do is simplify these exponents. Get all your exponents positive. So in the numerator, we have 3 s to the third. And this t to the -2 that's in the numerator, it's got to go to the denominator and become positive. And now what you can do is substitute. So in the numerator, we have 3 times 2 to the third. And in the denominator, we have -3 squared. All right, so you can type that numerator into your calculator. And in this case, you want to finish everything in the numerator and then finish everything in the denominator and then simplify. So if you type 3 times 2 to the third, 3 times 2 raised to the third equals 24. And in the bottom, -3 squared, that's -3 times -3, that's +9. So you got 24 ninths. Those are both divisible by 3. So 3 goes into 24 8 times, and 3 goes into 9 3 times. So we get 8/3. All right, I'm going to do a few more examples, and these are going to be when n equals -2. W equals 5. First thing we got is n to the -4th times w to the 0. So simplify your exponents first. All right, this n to the -4th has to go to the denominator and become n to the +4th. W to the 0, anything to the 0 power equals 1. So now we've got 1 over 2, -2 to the 4th. And in your calculator, you can type 2 negative raised to the 4th, push equals. So this will be 1 over 16. All right, write this down. A negative to, let's say, raised to. A negative raised to. You're going to say a negative raised to a even power. Equals a positive. A negative number raised to an even power equals a positive. And a negative raised to an odd power equals a negative. Sometimes that helps when raising negatives to different powers. All right, so let's try n to the negative 1 over w squared. So simplify the exponents first. The n's got to go to the numerator. So we go 1 over n to the first w squared. And then we can substitute. So that's 1 over negative 2 to the first times w, which is 5, squared. So that's 1 over. You can do this whole bottom in your calculator. All right. Negative 2 to the first power, that's a negative to an odd power. So 2 negative raised to the first equals, that's negative 2. So this is negative 2 times 25. So that's 1 over negative 50, which is negative 1/50th. All right, let's do one more. Let's do 1 over nw to the negative first. 1 over nw to the negative first. Now, you got to be careful here. This means n times w to the negative first. All right? The only thing to the negative first power here is this w, not the n. So when you simplify this, the w to the negative first goes to the numerator and becomes positive. And the n just stays on the bottom. It's to the first, but it's implied. It doesn't get written. And I don't have to write that either. So what was our w equal to? 5. So this becomes 5 over n is equal to negative 2. So that's negative 5 over 2, which is, if you want to simplify that, what's that, negative 2.5? All right, so anybody got any questions on any of that? Zero, negative exponents, simplifying. All right. Your assignment for today. If you're a Zoomer, it's a new handout. It's already been uploaded to the resources tab on Focus web page. So we got pages 421 and 422, doing problems 9 through 44. If you're a Zoomer, you're going to take a picture of that completed assignment and you're going to email it to me. If you're in class, you're going to drop it in the basket. Upon departure. Are there any questions in class or people that are in their living rooms, dining room, office, bedroom, sitting by the pool, on a golf course, out in your fishing boat? Any of those places? Taking algebra 2 on a golf course. Yeah. All right, if you guys don't have any questions, you are excused from this meeting.